Today we will basically discuss on commands, some commands and expression equations, how we can construct using equation, then alignment, then multi-line, how we can add in our equation, and how we can construct matrices, matrix equation. So there are lots of things we will try to discuss. So first, see, in LaTeX, basically we have to start with a begin equation and in equation. Say after starting begin document, in document, then we in between them we have to write slash begin equation slash and in equation. In between we have to write the equation, right? Here most important thing is we have to use basically symbols for mathematical symbols. If we are not using begin equation, in equation, we have to use for mathematical symbol. We need to use these dollar symbols, right? And this symbol actually indicates centering the expression. Instead of this symbol, we can write double dollar in both sides. Then also the equation will go to the center, right? And this is written for math size parenthesis, means if your equation is bigger, the size of the content is bigger, and automatically the parenthesis will become larger, right? So here some examples. Suppose this is the expression m square comma z. So it is we'll write in LaTeX as dollar m cap to cap means square then z, right? Close this parenthesis. So it will give you this expression. Similarly, if you write under dollar slash delta u minus k of x minus e cap twice e, it will give this expression. Similarly, for this expression, here we have to write slash under dollar slash inf inf means infimum, then n belongs to n means n in n, and in the set math bb, n means it is the symbol of mathematics. This you can say So to write this, we use this command, right? So n belongs to n, and for this bracket we can use plus set means set symbol and this bracket. Then for the fractional part we write slash frac 1 and n. Instead of defrac, we can write frac also, right? So writing this command, we will have this expression. Similarly, to write this expression, we have to write slash sum, right? N goes from n equal to this is called subscript. For subscript, we have to write this command. N equal to 1, cap means you can see here n goes from 1 to infinity, so slash infinity, right? And you can see here fraction component is there, so we have to write slash frac. You can write defrac or frac, problem same. So 1, then in the another bracket we have to write n cap 2 means n square, and which is equal to again frac defrac pi square, right? Slash pi cap 2 square, and then in another bracket it is 6, so it is pi square by 6, and right in this way. If you use double symbol, basically double dollar, then this expression will become this much, right? Similarly, come to some common function, trigonometric functions. Here. To write cos x, we have to write under dollar cos of slash cos x, right? Then slash arctan x. Similarly, for this expression, we have to write sqrt means square root, right? For here, see f of x, right? Under dollar f of x equal to slash square sqrt square root x square s cap 2, x cap 2 means x square plus 1, so it will give x square plus 1. Similarly, for this expression, we have to write slash sqrt box n, it will come into the n 1 n power of x square plus 1. So to the next part, it is simply x square x cap 2 plus 1. Similarly, for this theorem, we can create this theorem by writing theorem, begin theorem, end theorem. Say conquer inequality. For conquer, here you can see on E there is a mark. To obtain this symbol, we will have to write this way, right? And inequality, then it will come automatically as conquer inequality. And for this, see, if slash omega, you can see omega modulus omega is strictly less than slash infinity, it will give you this expression. And for this lambda 1, you see here you can use double bracket or double dollar also instead of this slash this box, right? This bracket slash instead of slash this bracket, you can write double dollar, and you have to again end with double dollar. Then it will bring in the expression into the center. So lambda slash 1, so it means lambda 1, then omega equal to slash infimum of u not equal to 0. See, u slash any q equal to 0 means not equal to 0, any q n means not equal to 0, slash here diffract nabla u modulus of nabla u cap 2, it will give you this expression. And slash this 2 means subscript 2, right? And upon slash under this symbol u square cap 2, right? This is norm symbol. So by using this command, we will have this theorem and it is achieved. And you have to complete that theorem. Fine. So in this way, we can write this expression, right? And this is left. For to obtain this bracket, we have to write slash left bracket slash bracket, then begin array. We will use array matrix, right? Here in the first component, it is minus delta, then u into u plus lambda into u. Then we use n symbol. In the next column, it will come the equality will come in the next column. Then again we are writing here n, means in the third column it will be this modulus of u f p minus 2, right? And again we are writing here n. In the last column we can write text rm in, right? Means in omega. So in this way we can write this expression. Similarly, for this expression, the command will be dismiss. We are coming in the practical session, right? Then we can write this De Morgan law. See, union of dismiss equal to complement of union of dismiss equal to indication of a complement, right? So to write this simple, use dollar, then left parenthesis big cup. Okay, no problem. We can to obtain this bigger union, we were writing slash big cup, and it goes from I to 1. So it is slash I goes from 1 and cap n, right? Then ai slash I, then right parenthesis, bigger parenthesis, right? And cap is complement this pass, which is equal to big cap. This is cap and here is cap, right? Then slash I goes from 1 to n, cap n, slash means subscript and cap means superscript, right? And ai or c, cap c, right? In this we can write this expression also. This is simple expression, a times b, a under dollar a slash times this product symbol b equal to the symbol. Then another way also you get symbol, no problem. So under AB slash such that A in B, A and B in B. So this will give this expression. Similarly, for this expression, our command is dismiss, right? For this expression, our command will be this one, right? Well, similarly, to write this here I have to, I forgot to say one thing. Here we are putting number, right? In my previous lecture, I told you that how we can bring a number in an equation. See here, if you write begin equation in equation, the number will automatically come, right? Now suppose instead of number we require this tag, right? E. So for this, simply we have to write slash tag under parenthesis E, right? This command will produce this statement. Remember, if we need some tag or a special character to express the equation, in such cases we have to write tag slash tag under bracket your required character, right? Here again it is 2 because we are using simply equation in equation, begin equation and in equation, right? And split means it is split it into two lines, right, two equations. But although there are two equations, number is 1, right? So this is an expression. So for this expression, our command will be this much. Finally, for a truth table also we can write easily using matrix array. You see here, tabular, begin tabular, in tabular, in between we have written here, see, $p pq, not negation of p, right? Negation of p implies p max q, right? So pq, it is slash is negation of p slash any q and slash neq p to p, this implies, and then we will have, after fill up all this text here, and then we will have this mass of truth table. Okay, so now come to the practical part. Suppose, yeah, I think this is, we will discuss writing equation, then numbering and what alignment. So first I want to start with a general statement, right? As audiences from different backgrounds, some maybe from arts background, so they basically need some sort of statement, right? They don't need a mathematical expression much more. So in this case we can write directly. I have written here a section statement. You can see here. Yeah, see, beginning document, after begin document we have written here section statement, then justify. I asked to justify. In our last presentation session, we forgot how to justify a paragraph, right? The code is simple, slash justify, and then we have to write the sentence under the bracket and this parenthesis. So then the statement will be justified. So this is expression or statement we have written. If suppose we need some mathematical term here, suppose x plus y, right? Here we need x plus y, then simply write $, in between this dollar, simply write x plus y and see, right? Yeah, see, this expression come into the PDF format, right? Similarly, other say here we are going to add what, x squared, say x cap 2, right? If suppose it is x1, say x, if we write in this way, slash 1 cap 2, it means x1 square, right? See here, this is x1 square. So in this way we can add symbols, mathematical expression in a statement in between the statements, right? So now come to some algebraic equation. Here you see uh, we are going to write here ax plus b equal to say y, right? Yeah, you can see here this is the expression ax plus b equal to y, and it is left justified. Here you can see because we use only one what $1 symbol, right? If we use double dollar here, then definitely the expression will go to the center. Well, we can see now. Yeah, here we can see the expression is now on the center, right? Again, this expression can be directly we can write, and it is left justified here also because we have written it where with a single dollar, right? Instead of this single dollar, if we write slash this bracket and slash this bracket, then also this expression move to the center. Yeah, you can see here, right? And for this expression was written using ax square plus bx plus c equal to ax cap 2 plus bx plus c equal to 0, right? In that way we can write ax cube minus bx square plus cx minus b equal to 0. Now come to the another important here I have used what begin equation in equation, right? So we can see, and here I have write what text less text. So in this equation and this number I will come, but here a number will come simply. See. Yeah, see here the number 1. This is the first equation we have written using big equation in equation, but the second equation we have written, but we command to take the equation with a, right? We go slash take a. That's why this appears here, right? Okay. Next, you can see this expression because here in a lot of symbols are there. Superscript, subscript, superscripts also all are there. See here, a1 into x1 to the power n plus a2x into x square, right? In this way we have written. So the tag equation A is this one, right? Okay. Then suppose we don't need a equation number, then we can use no tag or no number slash no tag slash no number. Even if we use hysteric symbol after equation, then also it will not produce the number. See here, this one, the first symbol. Here there is no symbol, no equation number, right? You can check it. Yeah, see. See, when I remove the tag, no tag option, then the number occurs here, right? Occurs here. If I use historic symbol here, then the number will not occur. Equation number. Yes, you can see here. and here fractional, this is fractional expression. For this expression we wrote the command, and it is a double column. Instead of this symbol we can use double column, double dollar, then slash for the fractional part, slash frac under bracket 1 plus twice x, numerator and denominator is under bracket x plus y equal to x minus y, right? So this is the expression. To obtain this expression, sum n goes from 1 to infinity 2 to the power minus n equal to 1, right? For this expression, the command is simple. Simply use sum, right? Slash sum and n goes from, right, n goes from 1 to, then use cap for power, right? Underscore means subscript. If we write underscore, it will come in the subscript, and if we write cap, it will go to the power of superscript, right? Then 2 to the power minus n equal to 1, right? This is the expression here. And for this expression, our command will be what? Frac 1 plus x under bracket, then in the another bracket 2 plus y squared, y cap 2, right? And whole bracket cap 2 equal to x cap 3, right? See, yes. Left, we have used left parenthesis and right parenthesis to obtain bigger parenthesis, right? Otherwise, what will happen? We will get a smaller bracket which will not cover entire expression, right? To obtain this expression, we have written what? This left bracket and right, slash right, and this bracket, right? Well, so then we can write product symbol. Product, then I goes from 1 to b, I goes from a to b, right? F of x, I say, equal to subscript I, right? Equal to 100. The expression is this much. Next, for this expression, our command will be what? See here, double dollar I'm using here for both sides. Then sum I goes from 1 to n, then I square, right? Equal to slash frac, the numerator is n into n plus 1 into n twice n plus 1, and denominator is 6. So the expression is this much. One important thing we can observe here, if we use single dollar, then you can see the difference, right? You can observe the difference in the expression. Yes, it is first of all left justified, and you see here some I goes from, it is with the summation symbol, not exactly under the summation symbol, right? If we use single dollar, then this sort of deficiency may occur, right? If we use double dollar here, then you see the difference. See, now I goes from 1 to n, it is under this summation symbol, and it is on the this summation symbol, right? This is the difference we can observe. Now for binomial expression, what our command is simple. Slash under dollar, right, slash binom, binom, right? Binom, right? Fractional, for a fractional expression we write with slash frac under bracket a under bracket b, then that produce what? That produces a by b. Here, if we simply write binom, it will produce this binomial symbol. The symbol is what? This much, right? Combination ACB, right? Similarly, here it is occurring in this place, means in the left, it is left justified because we are using single dollar, right? Here you can see A, C, B plus C, right? Means a combination combination a to b plus c, then it is n square minus 1 to 2n plus 1, right? So for this expression, simple. We use this symbol, that's why the expression is occurring in the middle, that is in the center, right? Or double, you can use double ruler, so no problem. The command is simple, binom slash binom a, and in another bracket it is b plus c into binom here fractional is fractional part is there, you can see, slash frac n square minus 1 by 2 to n plus 1, right? This is n square minus 1 by 2 n plus 1. Then we will discuss some calculus. Limit is to 0 f of x plus h minus f of x upon h, right? So for this expression, here we are using singular slash lim h tends to h slash row, right row means this cursor, right cursor to 0, h tends to 0, frac f of x plus h minus f of x upon h, right? It means another bracket. If we use double dollar, the expression will be in the middle, in the center, and it will be under h tends to 0 will be under lim limit, right? If you can check it. Yes. Here you see, right? Similar way we can we can insert some text also. This operator changes when used alongside text limit h to h x minus h, right? So for this we have written the same statement. The statement will be same, right? But the mathematical expression is slash this bracket, then limit x right row tends to h, right? In a similar way, for this slash integral fractional frac half of dx minus yes, under parenthesis left parenthesis we have written integral half of dx, right? This is the expression here. Yeah, integration half of dx minus this much can be written as in this way. Similarly, to obtain this expression, del t of u equal to h square and this mass, we have to write this expression, right? Begin equation without numbering, right? Is very simple. We are using here means then we don't need any number. Frac, so partial u means del u will come, right? Partial. Frac in the denominator, numerator it is partial u and slash partial t means del t, right? Then h square left this much. Using this expression, we will have this sort of expression. And for this expression, our command will be see here slash limit underscore x slash 2 positive infinity, then slash frac or defrac this expression, and in a new denominator this expression equal to 3, right? Similarly, we can write directly this expression by writing this slash int means integration underscore 0 means 0 to cap means 2 plus infinity x to the power n x cap n e to the power minus x, then dx equal to this, right? this was. Similarly, we can write another expression also. Here you see integration due to yeah, I have already told this one. So yeah, here integration slash int slash cos theta, it will give cos theta, then in d theta equal to slash theta means sin theta, right? Plus cos theta d theta equal to sin theta. In this way we can write this expression also. Yes, x square plus y square, right? This one, yeah. So and then if you write int x, oh yeah, this one. Underscore x square plus y square to LQ r square, right? It less than equal, this is less than equal, so LQ slash LQ r cap 2, it is x square plus y square less than equal to r square f of x dx dy equal to integration theta equal to 0, let's go theta equal to 0 cap twice pi 2 slash pi into integration r goes from 0 cap r means to r, this is the function is r cos theta r sin theta into r dr d theta, right? Yeah, f of r cos theta sin theta then r dr d theta, right? In this way the other expression can also be written. Yeah, this bigger expression can be written in the same way. Yeah, in non-relativistic, right? Where yeah, you can see here. In non-relativistic wave mechanics, the wave function this mass of a particle satisfies the Schrodinger wave equation, right? Here we have written the statement. To write the name, we use this code wave equation. I have referred equation here. Where we have this, in the above equation I use label equation 1 and I refer here. That's why you can see this equation 2 occurs, because this equation number 2 I referred, I label, and then here I refer, just to show how we can refer a equation, right? And we can write this expression using what? This less I h bar frac this partial psi partial t equal to frac this mass. Using this command we will have this sort of expression. Then come to equation versus getter versus align, right? So using this three expression, begin equation, in equation, then begin third getter, in getter, then begin align, in align, we can write expression. But what is the difference? What are the differences we can observe here? See. Yeah. Now first what? Begin equation, in equation. In between this code we have written x plus 3 into x plus 2 equal to x kept with x square plus 5x plus 6. Note x I have written, so the equation number will not appear here in the PDF, right? Then which is then I use double slash means next line, then greater than equal to x square, right? Slash z means greater than equal to x square, right? If I use this code, then the expression will be this much, right? After giving the double slash, the greater than equal to x square, it does not move to the next line. Right? Move to the next line. See, it will appear in the same line after even putting the double slash, means next line, right? Means in using equation, begin equation, in equation, if we put double slash, then it will not give the next line, it will occur in the same expression, right? Now come to begin getter and in getter. In between you can see we have written same expression here, right? Instead of equation we have written here GTS here, getter, right? Then we will have this expression here, you can see. And we did not use the expression no tag. Okay. We use no tag. Then also we are getting equation 3. Equation 3 is getting for this expression, right? If no, I did no tag, then we can observe the difference. Yes. Here the number is not occurring, right? But it is not aligned. You can see the symbol moved to here, right? It should be in between under this symbol, fine, and it will give by the align code. If we write instead of gather, if we write align symbol, align expression, right, then it will give this expression. Means I mean if we use begin align and in between we write align is used generally. How it is little bit different. See, here we use n symbol. After the first expression we use n, right? In here it is in the beginning, right? So it gives us this alignment, right? Next come multi-line. Multi-line means you suppose you have a equation but which exceeds your the margin of the PDF, say, right? Then how we can write such kind of expressions? Then we can use multi-line. Sorry. Then we use begin multi-line in multi-line, right? Where you want to break the line, you can use this symbol, right? After F, the expression will come in the next line. Fine? Yeah. After that, the characteristic is the first one will be left justified when the second line will be right justified. Remember. Okay. Suppose we need three lines, then our expression will be this. We'll write this way: begin multi-line, in multi-line. So in between we are writing x equal to this much. Then we need the next line, so we use this space. Then we have written the next line. Then we have given the double slash. Then the next line, right? Using this expression, we will have what? Yeah, here the characteristic is what? When the initial line will occur will be left justified, while the middle one will be centered justified. The centered will be occur in the center, and the last will be, or third will be left justified. The number is coming because we are writing multi-line. It will give the number. If we use asterisk symbol, then the number will not occur. Right? So check. Yeah, this one. See? In a similar way, we can move the statement, the middle statement to the right justified or right side, right? We can make it right justified by using what command? Yes, so right. So so right. If you put simply this is a command, so so v right here, the statement will go to the right? It will become right justified. In a similar way, suppose what it is written, the same statement I think I have written here. Yeah, this is a bit different. Oh yeah, right here I have written here left. So left, then this expression will move to or will become left justified. Move to left side, right? See here. So left, left. It means this the second line of this multi lines. It will carry the left side or it will be left justified. Okay. Then another one statement that is called equinary, right? So we can use the to obtain the how we can write or obtain such expression. Here, what is the difference? You can see. Suppose we are writing what? Begin align, end align. We are discussing about now what? Align versus equinary. So okay, fine. Align. We are writing begin align, then in align. In between this alignment, we are writing a n equal to b plus c first statement, first equation. Then the next equation we don't need any number right here. Then in the next line, this is the next line, and this is the final line, right? And the same statement we have written here using equinary, and we use here c a then n equal to n b. It will give us this gap, right? Gap plus c, right? Then n equal to n again, then it will give the gap. Then plus c. Okay, fine. Then we have used here double and symbol plus this symbol. This is a gap. It will also produce gaps less greater than. So n plus n this much, and n equal to n p plus this is the same statement. So so see the differences here. If we use align statement, we will have this expression. Here it is aligned, but the problem is, you see the alignment in equal sign is fine, but you can see deficiency in this symbol, plus symbol. It is also aligned with the equal symbol. So this is not aesthetic is not there, right? So we are talking about scientific aesthetic. So how this is more aesthetic, you can see there, right? It's beautiful. So to get this expression, we move this symbol from here to there. We use simply this equinary expression, right? And it gives us this expression. Then another expression equinary you can use for another purpose. Suppose, yeah, left. We are using this expression, say left eqn. Equation left. We are writing what? Slash left eqn, and under bracket this expression. We don't need number in that expression. Then we are writing n equal to n this much, and then in the next line it is this much, right? And it produces this expression. Here we did not use we used no number. That's why no number is there. Fine. If we remove the expression, say left this much, then the expression will become C. Here it comes to here, right? So to make in the same line, we use this left equivalent equation, right? Now come some cases. What is cases? Cases mean if we need to write an expression using bracket, right? Suppose fn equal to this much. To obtain this bracket, we use cases, begin cases, in cases, right? In between begin and in, we write these expressions. Here, begin equation, in equation. Then after that, we are writing what? F underscore n. This is fn equal to, here you can write, see, begin cases and in cases. In between begin and in, we have written 0 and this much, 1 and this much, right? Fn and the last expression, right? So using begin cases, in cases, it gives this bracket. Next, we will talk about matrices, right? How we can write matrix equation? Simple. See here, matrices. Begin P matrix and in P matrix into V equal to 0. This is the expression, right? In between this, we can write A, and like table. In table also we have written, or we generally write, but A and B and C. In the first column it is A, in the second column it is B, in the third column it is C. In the second line again, if we write in this way, it will produce this. Yeah, P matrix means, and the shape is this much. This is the shape of a P matrix. Instead of P matrix, we can write what? This, if we use this manually, slash this bracket and this left slash left, then slash right, and under this bracket if we use this matrix, simply matrix, then it will produce this matrix, right? This can be written another way also. In next, yeah, B matrix. Using B matrix, we will have also this expression. Yeah, this. We are coming to dot matrix. Wait, yeah. Suppose begin matrix and in matrix, in between, if you write, if we don't put any what, this is not a bracket actually, this is double dollar, this is also double dollar. If we don't use any symbol before begin matrix and after in matrix, then no bracket will occur here, right? This is simple. A11 we put first, right? This is underscore A11, and C dot means it will give 3 dots and A in slash 1 in, then V dot, vertical dot, then D dot, V dot, right? Vertical dot is called, this dot means we're writing D dot, diagonal dot, right? Then vertical dot again. In this way we can write this sort of dot matrix. If we use V matrix, then we will have this determinant form. This is V matrix. Begin V matrix, in V matrix. Then in between V matrix, you write anything, whatever you want. Then it will give us this one. Suppose to obtain this sort of expression, we generally use in what LPP problems, we use substack, right? Using substack, we will have this sort of expressions. Yeah. See, double dollar, it means it will occur in the center. Slash mean slash sub slack a plus b plus c equal to 20, right? Then abc is z greater than equal to 0. Then we are using this slash, right? Sorry, underscore. When underscore is using, it means it will this expression will come then what below under the sum, right? So we are using here double dollar like symbol. If we use this symbol, it gives it brings the expression in the center. So we are getting this expression in the center. Minimum of f of x, right? See here, minimum of f of x is not in the under the bracket, it's outside bracket, right? F of x, we write first mean underscore slash substack slash x as x in s, then next line x greater than 20, right? Yes, then f of x. For this expression, our code is simple. Double dollar say slash sum underscore, there are three expressions. Substack under bracket, we have to write a plus b plus c equal to 0, abc greater than 0, then in the next line a plus b greater than 5, and into abc. Yeah, this is abc. So in this way we can write this sort of expressions. Some trigonometrical functions, say how we can write. Okay, yeah, well, see, we are using here begin alignment command slash sin a slash cos a and equal to frac, this is half 1/2 left bracket, then right bracket here, then slash sin a minus b plus sin of a plus a. In this way we can write this expression, and we are asking for what tag, right? So that's why in this tag DFG are coming. In the tag I wrote DFG. That's why we are getting this expression, and these expressions can be written easily. See, double dollar means if you occur in the center, then in slash integral, then fraction d theta upon 1 plus theta squared theta cap 2 equal to 10 cap minus 1 means then inverse theta slash theta plus c, right? This means. And in a similar way we can write these expressions, right? Simple expressions, right? So we will have this sort of expressions. Now remember one thing, we are getting here exactly a number 1, 2, 3 like this way, numbers are right. When we are asking for tag, then only we are getting this sort of expressions, right? But if you need equations under section wise, right, then what we will have to do means suppose it is section under section 2, we are writing a equation, then equation will become 2.1c, right? We need in that way, then simply add this. Yeah, if we add this expression slash definition the equation under bracket the section means the section, under section the equation number will be given, right? Dot Arabic equation. Here we are given Arabic, that's why numbers are will occur in Arabic. So now we can check. Coming or not? Yeah, you see under the section 5 the number is 5.2. So in this way we are writing this equation under multi-line under section 6. So the number first is 6.4, then 6.5, right? In this way we can have these expressions and numbers. With this, I think I should conclude. Hope you have learned little bit of things from this lecture. If you have any